Welcome back, scholars. Today we're going to take a look at how to simplify complex rational expressions. These algebra skills will come in handy right away as soon as you start AP Calculus. Let's get started. When we say complex rational expression, we're referring to a fraction which contains a rational or a fractional expression in either the numerator or the denominator. It ends up looking something like a fraction sandwich. Our goal when simplifying these expressions is to generate a rational expression with a non-rational polynomial numerator and denominator. We'll look at two examples starting with this one. Before you get started, go ahead and look for any restricted domain values before simplifying. Once we write the expression in lowest terms, there's a pretty good chance that the excluded values will no longer be apparent in the final expression. I can see that x cannot be equal to 0, -1, or -2. Next, our goal is going to be to rewrite both our numerator and our denominator as a single rational expression, so we'll need to use a common denominator in both cases. Let's focus first on the numerator. I've got 2 over x plus 1. I'll rewrite that 1 as x over x. Then, combining across the numerator, I have 2 plus x over x. Let's focus now on the denominator. I've got 1 plus 1 over x plus 1, so I'll need a common denominator of x plus 1. Let's rewrite that 1 as x plus 1 over x plus 1. Again, adding across the numerator, I've got x plus 2 all over that common denominator of x plus 1. What I'm going to do next is go ahead and restate this complex fraction using my new numerator and my new denominator. Then I'm going to rewrite this quotient, that's division, as a product, an equivalent multiplication expression. To do this, I'm going to leave the numerator alone and multiply by the reciprocal of the denominator. So that will be x plus 1 over x plus 2. Let's go ahead and leave this in factored form for a moment and look for any common factors that can be reduced between the numerator and the denominator. It looks like I've got a factor of x plus 2 in both the numerator and denominator, so we can simplify this down to just 1, and that leaves our final simplified expression as x plus 1 over x, where x is not equal to 0, -1, or -2. Next up, I have an expression with a rational expression in the numerator, so we'll tackle this one exactly the same way. Again, let's start by identifying any domain restrictions, which this time will be 0 and -1. Now, let's simplify that numerator by writing this rational expression over a common denominator of 1 plus h. I've got 2 over 1 plus h minus 2. I'll rewrite this 2 as 2 plus 2h over the 1 plus h. Now, be very careful here to distribute the subtraction to both the 2 and the 2h. Once we combine like terms, our new numerator should be -2h over that 1 plus h common denominator. Once again, I'm going to restate that complex fraction using my simplified numerator over that denominator h. Now, I'm going to rewrite this quotient as a product. That means multiplication. I'm going to leave the numerator alone and multiply by the reciprocal of the denominator. That'll be 1 over h. Again, let's leave it in factored form for just a moment and check and see if we can reduce any common factors between the numerator and the denominator. We can reduce this h over h to just a 1, so that means our simplified expression will be -2 over 1 plus h, where h is not equal to 0 or -1.